In this video, we will learn how to differentiate functions of the type y equals f of x to the power g of x. Remember, here g of x is a function and not a constant value, okay? Which basically means you cannot use the power rule to differentiate this function. So, the question is obviously then, how do we go about differentiating this? So let's use an example of a function in this form. So let's take y equals x to the power x and learn how to differentiate a function. Clearly, you see here the power is a function and not a constant. Okay, so the best thing to do in these situations is to take the logs of both sides. So if I were to take natural log of y, I have natural log of x to the power x as well. Here we can use the identity for log, which is natural log of a to the power b is essentially b times natural log a. Okay, so therefore this function essentially becomes ln y equals x times ln of x. Now we are ready to differentiate both sides. Now what you need to keep in mind is that when you differentiate the left-hand term, which is this ln y term, you have to account for the fact that y itself is a function of x, which means you have to use the chain rule appropriately. Okay, so I'm just going to write this additional step that just shows you that, okay, we are about to differentiate everything. So I'm just going to write, okay, and so this implies the derivative of the left hand side, which is ln y, is 1 over y times y prime. Once again, I want you, to remember that this is the part that people forget here. Okay, so you have to realize that y is a function of x, and therefore, when you differentiate anything which is a function of y, in this case, which happens to be ln y, you will have 1 over y multiplied by y prime. Okay, and the right hand side is a simple product rule here. So let me just work this all out. So it is x prime times ln x plus x times ln of x prime. Okay, so this tells us that y prime all over y is equal to the derivative of x is 1 times ln of x plus x times the derivative of ln x, which is 1 divided by x. Okay, so let's just simplify this one more time and write as ln y prime over y equals ln x plus 1. Now we are ready to isolate y prime, and we can write it as y prime equals y times ln x plus 1, and we can finally replace y with x to the power x times ln x plus 1. So this is the derivative of the function x to the power x. Let's take another example and differentiate the function, let's say y equal to, say, ln x to the power, let's just say, tangent of x. Okay. Once again, we are in the situation where we have a function of another function. So we can again use the laws of logarithms. So we can write it as ln y equals ln and of ln x to the power tangent x. Let us first simplify the right hand side, and I can rewrite this as tan x times ln of x. We're now ready to differentiate both sides. So let's write down the derivative of the left hand side, which will be, so this is where we're going to differentiate. Okay, so the derivative of the left hand side is going to be 1 over y times y prime, which is equal to, now here we will use the product rule. So I can rewrite this as tan x prime ln of ln x plus tan x times ln of ln x, the whole thing primed. So be very careful here because it's easy to make mistakes. Okay, so my left hand side becomes y prime over y, and all that is equal to, now the derivative of tan x is secant square x ln, okay, multiplied by ln of ln x plus tan x. Okay, now we have to differentiate this ln of ln x term. So clearly you notice that this is a chain rule situation. So the first thing we do is differentiate the outermost function, and we get 1 over ln x. And now I have to multiply this by the derivative of ln x. So all this becomes y prime equals y times secant square x ln of ln x, which is all taken care of, plus tan x times 1 over ln x times the derivative of ln x is 1 divided by x. So this tells us that y prime is equal to, now at this stage we can replace what what y itself is with, it's a function of x. So it is ln x to the power tangent x multiplied by secant square x ln of ln x plus tan x divided by x ln x. Okay, hope this video helps in differentiating functions of the type f to the power g, where the power itself is a function.